everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over official guide number 3, problem solving and data analysis. This video will cover the problem solving and data analysis section of the official digital SAT study guide, a preparation book made by College Board. Please support the book by purchasing your own copy using the link in the description. I recommend you complete the questions before watching this video. You can follow along beginning on page 254 in your own copy of the 2023 edition. Let's get started. Okay, this first question talks to us about, it says the ratio of adults to children is 5 to 1. So we could kind of view this as like 5x and x, and we could call the total amount of parts 5x plus x, which is 6x. So that means the fraction for children is the children part, which is x over the total, which is 6x. And that gives us 1/6. We can now multiply that fraction by the total. So 1/6 times 240. And we should get the total number of children. So let's see what that gives us. We get 40, which is answer choice A. Very similarly, if we wanted to find the total number of adults, we would do 5/6 times 240. Great. Okay, very first thing I'm going to do is I'm going to convert these to the, using this conversion factor to their actual lengths, because it wants the actual floor area. So why don't we do that? So 3.5 inches. I'm going to put the inch on bottom and the feet on the top. Inches cancels out and we're left with feet. 3.5 times 3 is 10.5 feet. And we can do the exact same thing for the other length, 5 inches. And once again, being very careful to put the unit I want to cancel on the bottom so that it's on opposite sides and I can cross it out. 5 times 3 is 15 feet. Now, area is length times width, so we should be able to multiply those guys together. So 10.5 times 15. Let's see what that gives us. 157.5 square feet, which I believe is answer choice D. And that is correct. Very good. Let's keep going. Okay, this one is also a unit conversion. It wants us to change 1,060 kilometers to miles. Again, guys, if you haven't watched the Ottocento unit conversions video at this point, you really should check it out. I'm going kind of fast here because I'm assuming you've already watched that. 1,060 kilometers. And then it says 1.6 kilometers, 1 mile. Okay, so I'm going to put kilometers on the bottom so that, see how these guys, the kilometers are on opposite sides of the division sign now, so that means they cancel. And we're left with units of miles, which is what we want. So now all we got to do is put this in a calculator. Again, as they get more complicated, you can just make sure that you type it into a calculator exactly as written. That way you don't make a mistake. Okay, so I'm getting 662.5. So let's write that down, 662.5 miles. And that seems to be approximately answer choice C, which is correct. Okay, so it wants us to find the population density in people per square mile for all of County Y. Okay, so what we have to do is we want to do people. I'm going to put this off to the side. People per square mile. Remember, per means division. I go over this in the Otogento video. And so the total number of people, we don't know, but we do know the total number of area is 30 square miles and 50 square miles. So that should be 80 square miles. And to find the people, we're going to have to do the density, people per square mile, of each district times the square miles to cancel out the square miles and be left with people. So that's what I'm going to do. 30 miles squared times 370 people per square mile. And you see the square miles cancel and we're just left with people. So 30 times 370 is 100. I think I did that right. And now we got to do the other district. So as you can see, it's kind of the same thing. So 50, I'm not going to write it all out. 50 times 290. 50 square miles times 290 people per square mile. 14,500. So now the total number of people, we just add those up. 25,600. And 25,600 divided by 80 gives me 320 people per square mile. Great, that's it. So oftentimes, once in a while, they'll give you a question where you have to kind of pay attention to the units to see if you need to multiply or divide stuff. So that's kind of what we did here. Great, let's keep going. Okay. All right, so it says we've got a couple percent multipliers going on. We've got 75% more, and we've got 15% more. Okay, so those both sound like increases. Remember, guys, for an increase, we do 1 plus percent divided by 100 to find the percent multiplier. And I would not do it in my head because as the numbers get trickier, it becomes really hard to do in your head. So I'm going to do 1 plus 75 over 100. 1 plus 0.75 gives me 1.75. And now I'm going to do 1 plus 15 over 100. And I'm just going to jot these kind of both down. Oh, let me do that. So this percent multiplier is 1.75. And this percent multiplier is 1.15. Great. So it says for a particular style of table, the usual price of the table is usual. I'll use U for usual, is 75% more than the cost of the table from the wholesaler. So how about I put 1.75 the cost of the wholesaler? How about W for the wholesaler? And it says during a sale, the store tells the table, okay, so sale, why don't we use S for sale? 15% more than the cost from the wholesaler. Okay, so we'll do 1.15 W for wholesaler. And now it says if the sales price is $2.99, what is the usual price? Okay, so you could plug in S, solve for W, and then plug in for the other one. So why don't I do that? So if the sales price is if the sales price is $2.99, and then we divide both sides by 1.15, we get W equals 260. And now you can plug that into the first one. So 1.75 times 260 and we get a U of 455, and that is answer choice B, and that is correct. Now, something I want you guys to be aware of, because a harder question, and I've already seen this on the DSET, is like when there's like kind of a mutually shared variable, often what we do is we get that letter by itself and then relate the other two letters to figure out the percent between them. So let's do that really quick just for fun. So I'm going to get W by itself for both of them because that's the common letter. So for this one, if I divide both sides by 1.75, I get 1 over 1.75 U, which is, I just did that on a calculator, 4/7 U. And then this one, if I divide both sides by 1.15, I get 20 over 23 S equals W. And see, now they both have W by themselves, so I can set them equal. So I can write 4/7 U equals 20 over 23 S. And now I'm going to divide both sides, how about by 4/7? And I get another really messy fraction. You can tell this problem wasn't really designed for this. 35 over 23. And maybe a question they'd ask you is, what percent greater is the usual price than the sales price? And we could go over here and do 100, take away 1 from the percent multiplier. I talk about this in the percents video. What was it, 35 over 23? And then multiply it by 100. So you see the usual price is about 52% more than the sales price, and that seems to check out. Anyway, just that kind of skill. I've gone over this in other videos at this point. It's just, this is probably something you want to know how to do, is like how to, when you have these two kind of word problem equations with a shared letter, get the shared letter by itself and then set them equal. That's a really good way to approach it. These numbers were just kind of messy, so they gave you a number, that's why. Makes it a little easier. All right, let's keep going. All right, this one. So first it says, how many pints of raspberries would the grocery store be predicted to sell in a week when the price of raspberries is $4.50 per pint? Okay, so again, talked about this a bunch. The actual y values, why don't I put this at the top because I'm going to run out of space. The actual y values come from the dots, and the predicted y values come from the line of best fit. So make sure you understand that. Okay, so it says a price of $4.50 per pint. Okay, so that's here. And you see there is no dot there, so there's no way for us to get confused. But if there was a dot, we don't care about the dot. We want to go to the line because the question says predicted. So we're going to go like right there. And then we just kind of read it across. Seems like it's about 90. But they want an exact answer. Ooh, here we go. They gave us an equation, so we don't really need to look at the graph. We can just plug in 90 for x. So 233 minus 32 times, not 90, the x value, which is 4.5. And let's see what we get. 89. Great. So we were really close. So 89 pints would be sold, and that is the correct answer. Great, so make sure you understand this very important distinction, even though it wasn't too important for this question, that the predicted y values come from the line. You can use either the line on the picture or the equation. And the actual y values come from the dot. So like, for example, if I was like at this price, the actual y value is here, not on the line. Okay, great. For how many of the 19 weeks shown was the number of pints of raspberries sold greater than the number of predicted by the line of best fit? Okay, so it wants to know the number of pints, so the actual number of pints when it is greater than the number predicted. So this is what I do so I don't get confused. I always write this out, and then I try to get actual on the left side. Actual is already on the left side, so I don't think we need to do anything. But you might get a question where they kind of flip it on you. They say, oh, the number predicted is greater than the number actual. And lots of people would say, oh, that's above, but really it's reversed. So if you flip the inequality, when you get one that's kind of backwards, you won't fall for any kind of trap answer. So anyway, so actual's on the left, so that's good. And so I can just kind of interpret this. So this greater than, it's basically asking me how many dots are above the line. So let's go through and count how many are above the line. So 1, 2, 3, 4, 5, 6, 7. Did I miss one? Oh yeah, this one right here. 8. Great, very good. Okay, so there are, it's basically asking you how many dots are above the line. So there's 8 dots above the line. So writing down that inequality, literally translating word for word what they told us, and then making sure actuals on the left side of the inequality, it makes it a lot easier to interpret. So don't just see the word greater than and then go, oh, it's asking me above. That's not necessarily true. You got to read it carefully. All right, great. Interpretation of the slope. Okay, so slope is the change in y when x goes up by 1. So the change in y when x goes up by 1. So I'm just going to type this, I think. It'll be easier. So it'll be something like this. For each additional x, so in this problem, for each additional, how about $1 that the price per pint increases, the store is, and this is really important, predicted to sell whatever the slope is. So it'll decrease. So sell, decrease. They'll lose 32. In other words, they'll sell them 32 fewer pints of raspberries. We'll break this down a little bit, but the really important thing that you guys make sure you include that makes this different, guys, is that this is a line of best fit. So you have to make sure, this would be a multiple choice question, right, on the actual test. You have to make sure you include the word predicted because it's not telling you the actual y value. The line of best fit tells you the predicted y value. So for each additional x, in this case, increase in x. So in each case, in this case, the x is the price per pint. Okay. The y, the pints of raspberries sold, the slope is negative 32. So it goes down by 32. So that's kind of the idea. If it were positive 32, maybe we would say they sell 32 more pints of raspberries, something like that. Again, this would be easier with, answer choices in front of you. Okay, great. Let's keep going. So the next question is asking about the y-intercept. So the y-intercept is the y value when x equals 0. So if the price per pint that's the x, right? If the price per pint were $0, x is 0. And then you plug in 0 and you can see it's 233. The store they wouldn't sell them because they're $0, right? So they would essentially give away 233 pints. So as you can see, for this context, that's not really applicable. It doesn't make any sense. They're not going to just start giving away 200. They're not going to start giving away pints, and even if they did, they'd probably give away way more than that, right? So kind of the concept they want you to understand here, and this is something you learn about when you take statistics. Not all data sets are appropriately modeled by a line of best fit. Sometimes they're quadratic or exponential or something else. So maybe this curve is really, my guess would be, this is like, in this snapshot, it fits a line pretty well, but if you expand it, it maybe like looks more like an exponential, because as they increase the price, less and less asymptotically, less and less people are going to buy. And as they decrease the price asymptotically, more and more people are going to buy, assuming nothing else changes. So it's probably maybe better fit by some kind of exponential or curve. So that's kind of the idea. So there really is no right answer to this question, but that still is kind of the idea, is that, okay, it's the y value when x equals 0. So y equals 233 pints when x equals $0. Very good. Let's keep going. All right, sample question 7. Okay, so see how all these, they're just going up by 1, but then these guys are going up by different amounts. So it goes up by 3,000, then like, I don't know, 12,000 or something, and then a much bigger number. So the point that I want you guys to realize is, by looking at that, you know that it does not have a constant rate of change, so it's not linear. So without doing any work, we can just quickly look at it and understand that it's not linear. So if there's any linear answer choices, it's probably not right. So A is linear, that's y equals mx plus b. And B is linear, that's also y equals mx plus b. So those are both wrong. Okay, so right away, we don't even need to do anything. We could just kind of start plugging in numbers. If we plug in 0, we get 1,000. But if we plug in 1, only in D do we get 4,000. So that's kind of the idea. If you wanted to, I'm not going to do this, but if you wanted to, you could plot this table on Desmos and then graph the function and just verify that everything goes through. There's another thing you could do. I would probably just cross out the first two and then plug in numbers at that point. Not really any other reason. Because, right, it's like interpreting these negative exponents is kind of tricky, and doing that organically is kind of hard. So you might be better off just guessing checking. Again, you have a very high chance of getting this question right if you just look at it and realize that the x is going up by the same amount each time, and the y is not. So if you realize that, I don't know, what's 64 minus 16? If you realize that, you instantly understand that it's not linear because it does not have a constant rate of change. So A and B are out right away. Great, let's keep going. Okay, question 8. Every month, Jamal adds 2 new books to his library. Okay, great. So if you want, we could come up with a little like example. So let's say his months and then his books. So how about at the beginning, he's got 6 books. Then every month we add 2. So 8 10, 12. That's a constant rate of change, and it's going up. So it's definitely increasing. So B and D are wrong because he's adding books. So that's increasing. And it has a constant rate of change. He's adding 2 new books. So if it's got a constant rate of change, that means it is linear. So this is increasing linear, which is answer choice A. If you came up with your little example like I did and you plotted it, you would see on Desmos, you'd see it would make a straight line. That's another thing you could do to help. So typically when there's an exponential function, there's some kind of multiplying word like double or triple, or it went up by 50% of the previous month, something like that. This does not have anything like that. It just says adds 2 new books. So we literally add 2. Adding a number or subtracting a number over and over and over and over again, that's a linear function. Great, let's keep going. Okay, really important to understand, guys, that this is not a distance graph. It's a speed graph. So we don't need to calculate the slope. This literally is the speed. So I'm just going to make this more obvious to everyone, I'm just going to label all these. So 17.6 to 19.8, that's here, so that's A. And then this one is B. And then 34.8. I think they just go in order. This one's C. And then 35.6 to 54.6, that's D. Okay, guys, so remember, it's asking where is the speed the greatest. It's not asking about the acceleration. So like the slope, I thought it was a distance graph and like the slope would be the speed. No, it's a speed graph. So you just literally read it. So which one has the greatest speed? Oh, well, it's the highest one, B. That's it. It has a higher speed. If this were a distance graph, then the one with the highest speed, I don't know, there isn't really a good answer, but I would want to say like A because it has the biggest positive slope. I don't know. It's kind of not really designed for that, so question, but just always pay close attention to what they're asking you and what the axes labels are. Great. Okay, let's keep going. Okay, this is a classic question. This is a conditional probability question, I think. It says, this is really important, given that the animal's mass is greater than 55, so that's a target group, so we should put a box around that target group. So I'm going to greater than 55, so that's all we care about. We don't care about anything else in the table. And now it says we want the probability of selecting a leopard. So we want the leopards. And remember, probability is desired over total. So we're going to do the total, which is 29. That goes on the bottom. We don't care about any of this other stuff, just the greater than 55 kilograms, because it said given. It means we're only looking at that group. And the leopards is 25. So we're going to put 25 over 29. And that is answer choice A. So yeah, pay very close attention. When you see a two-way table on the SAT, it's often asking you to look at, not always, but a lot of the time it's asking you to look at some target group. So it might say like, oh, if a leopard is selected at random, then that means you look at the leopard row and nothing else. So always make sure you pay close attention to that. There's probably more formal names for it, but I call it a target group. Great, let's keep going. Okay, this one is not so bad. This is just classic, calculate the mean, the median. So first thing I'm going to do is label the bars. So this is 6, this is 17, this is 9, this is 5, this guy's 1, and this guy's 2. And they told us there's 40 employees, so that means that N is 40. And mean is sum divided by n. So it might be easier if I just do this on Desmos. So the mean is, I'll do, how about A for average? We're going to do n is just 40, so that's what goes on the bottom. And then the sum, when you have a histogram or frequency table, that's what this is, a histogram, is we're going to kind of multiply and add all these numbers. What's kind of confusing about this one is that finding the median is going to be, finding the mean is going to be a pain because we don't know exactly what these numbers are. So I don't know, why don't I just pretend it's like the number halfway through? I feel like that'll give me a good estimate. So 6 times 15 plus 17 times the middle number there is like 25. Oops. Plus 9 times 35 plus 5 times 45 plus 1 times 55 plus 2 times 65. Okay, it seems like my mean is 31, about. And I probably could be more scientific about this, but I'm kind of halfway considering A and B wrong. Okay, so why don't we do the median and see what we get? So the median, the position of the median is n plus 1 divided by 2. So we're going to do 40 plus 1 over 2. And we get 20.5. So let's come back over here. So position equals n plus 1 divided by 2. 40 plus 1 divided by 2 is 20.5. So that tells us we have to take the average of 20.5 is between 20 and 21. So the 20th and the 21st. Now I add cumulatively until I hit one or both of those. So 6, haven't hit it. 6 plus 17, 23. Okay, so we know the median has to be in here in this box between 20 and 30 because 17 plus 6 is 23. So both the 20th and 21st must be in there. Include left, exclude right. So the median has to be between like 20 and 30. And it cannot be 32. No way, Jose. So this is out. I'm heavily leaning towards answer choice C. And let's see if that's right. It is, yep. So if you wanted to be really scientific about this and like prove to yourself that A and B are wrong, that you can't cross it off based on the median because the median could be 22, it could be 24, or it could be 26. So you kind of have to use the mean. What you could do is you could find the mean assuming the lowest number. So like 10, 20 for each of those bars instead of using like 15. And then you could find the mean assuming the biggest number. So like 20, 30, 40, 50, 60, 70. And then you know the mean has to be in between there. Seems like a lot of work. I think my way of just kind of guesstimating was really good because like sure, like 31 isn't our answer, but like that's really close. So it's probably that one of those two answer choices. I think using process elimination was good here. That's all I'm saying. But make sure you understand how to calculate a mean and how to calculate a median from a frequency table or histogram. All right, let's keep going. Okay, this is testing us on standard deviation. Standard deviation is a measure of spread. You never have to calculate it. They just test you on the concept. So you see these ones are kind of clumped together, and these ones are all equally spread out. So class B is more spread out on average. So it has a higher standard deviation. That's all you got to know. So whatever the more spread out one is, has a higher standard deviation. They'd only be equal if they were geospatially the same. Like if this one was all flat and this one was all flat, or like this one was like shaped like this and this one was exactly shaped like that. So only if they look like mirror images of each other do they have the same standard deviation. So we got to find an answer choice that sounds like B having a higher. So class A is the smaller one, B is the bigger one. So that sounds like answer choice A. And that is correct. So the standard deviation of class A is less than that of class B because class B is more spread out on average. And again, kind of the giveaway is that these guys are kind of closely clumped together, whereas these guys are kind of evenly sprinkled all over. I feel like the actual test would make it even more obvious, honestly. All right, let's keep going. Okay, so it has a mean of 342 pictures with an associated margin of error of 18 pictures. Okay, so I actually went over this in my Ottocento video on margin of error and confidence interval. So we do the confidence interval is the point estimate, in this case our sample mean, plus or minus the margin of error. So we're going to do 342 plus or minus 18. And 342 minus 18 gives me 324. And 342 plus 18 gives me 360. So the confidence interval is 324 to 360 pictures. And right away, I'm going to pick an answer choice with both those numbers in it. And unfortunately, they all have those numbers in it, so that doesn't help. So you got to really understand what the confidence interval means. It tells you that it is plausible that the true population mean is in that range. So right away, I'm seeing plausible. I'm already thinking C or D. This language, all the batteries, that's way too extreme. You can't say that for sure. You know, we only took a random sample of 100 batteries. We didn't look at all of them. So that's definitely wrong. And let's see the difference between these guys. It is plausible that the mean life of batteries produced by the company that day is between 324. Okay, that seems important. This next one says it is plausible the mean life of all the batteries ever produced by the company. Okay, if this company has been in business for like 30 years, that certainly doesn't seem reasonable. It doesn't mention that specific day, but C certainly seems more reasonable, and C is correct. Okay, so lots of good words in here. Plausible, that day, and then the mean life of batteries, and we got the numbers that we came up with. So yeah, I think this is the problem with D, ever produced. It's not taking the batteries from that have ever been produced by the company. It says from the daily output. So I would say the word day goes with daily. So that's probably your giveaway that it's C. Great. If you're still confused on this, please go watch my Ottocento video on confidence interval. It's super helpful. Great. Let's keep going. Okay, this is a statistics conclusions question. This year, all students in the course were offered additional audio lessons. The students who take these additional audio lessons did better in the course. Based on these results, which of the following is the most appropriate conclusion? Okay. I think I need to pull up like a chart for this to make sense, so give me a second. Okay guys, so if you want to take a second to jot this down, this is from the book and this is something they test you on once in a blue moon. So you can pause it if you want. So there's this really important idea of random selection versus random assignment. So consider that you have, like, you're trying out a new medication, say to treat cancer or something. The people that you select to be a part of the study, that's random selection if you did it randomly. And then assigning which people get the new treatment and the old treatment, that's random assignment. So it's kind of two different things. So like you select the people and then you assign them to a treatment. You're not going to see experiments a lot on the SAT. Most of what you see on the SAT is called a survey. So there's not going to be any assignment. So in that case, the random assignment, kind of distinction, not randomly assigned to treatments, is kind of irrelevant. But sometimes you do get questions with experiments, like I think this one is. So great. Okay, so I'm going to make this smaller so that we can read the question. All right. So it says, Community Center offers a Spanish course this year. All students in the course were offered additional audio lessons they could take at home. The students who took these additional audio lessons did better in the course than students who did not take the additional audio lessons. Based on these results, which of the following is the most appropriate conclusion? Okay, so really important. I noticed they don't really select anyone at random. They actually offered it to everyone. So that's kind of a problem. Like, people are volunteering to take the lessons. They didn't get assigned. So that's a big issue. They also weren't randomly selected. They're kind of putting them, so they weren't randomly selected. It's just everyone in the class was given this option. So there's a ton wrong with this. I'm already thinking, we are in this row where it's not random selection or not random assignment. And even if we were, we could only generalize it to the people in the community center course. So right away, any foreign language course, that's definitely wrong. Or who takes a Spanish course, that is also definitely wrong. Because we're not studying those populations. See, this one says, for the students at the community center who took the Spanish course. This one seems really convincing because it is talking about our population, but we did not do random selection or random assignment. So it says, I think we didn't do either. I mean, we definitely didn't do random assignment. I think we didn't do either. So the results cannot be generalized to the entire population. And also, conclusions about cause and effect should not be drawn. So you see, we can only get conclusions about cause and effect when we have random assignment. We didn't have random assignment. So we're going to go with answer choice D. No conclusion can be made. No conclusion about cause and effect can be drawn. So it's kind of that, how do you say, kind of the big problem is that we didn't do random assignment. So we can't draw conclusions about side effect. An example of random assignment in this context would be like, let's say there's 50 students in the community center course, and we randomly assign 25 of them to get the additional lessons, and we randomly assign another 25 of them to not get the additional lessons. So see how the students aren't choosing to take the lessons. That introduces bias or could skew the results. you have to randomly assign them. So it's like, no, you don't have a choice. You're doing the additional audio lessons, and then you 25 kids, you're not doing the additional audio lessons. So that would have been a better way to go about doing it. We didn't really select at random or randomly assign, I don't think. I mean, it doesn't matter. We did all the students in our population, so whatever. The big takeaway is we didn't do random assignment. That's the big thing they want you to take away from this question. So, okay, very good. All right, let's take a quick break. We'll come back with the drills. All right, let's get started with the drills. So 5,400 square foot room, if there should be at least 8 square feet per person, what is the maximum number of people that could attend this event? Okay, so at least that's greater than or equal to 8 square feet per person. So square feet is 5,400, and then per divide person, we don't know, so x, so it should be something like that, at least 8, and then square feet per person, that's 5,400 divided by x. Okay, so I'm going to multiply both sides by x. I get 5,400 greater than or equal to 8x. I'm going to divide both sides by 8. And I get 675 is greater than or equal to x. If I flip the inequality, I get x is less than or equal to 675, which makes way more sense. So always try to get the variable on the left side when you have an inequality. And remember to flip the sign when you do that. And we should get answer choice B, which is correct. So the most that we could have is 675. If it said less than, we would maybe do 674 because we can have like a fraction of a person. So great. Okay, water flows at a rate of 6 gallons per minute. How many gallons of water will flow from the pipe in 8.4 minutes? You could do a unit conversion, but why don't, for the sake of simplicity, we just use a proportion? I don't know, it doesn't really matter. Gallons per minute, so 6 gallons for every 1 minute. And then we don't know how many gallons of water, so we could put x, 8.4 minutes. Now I can just cross multiply, so I get x equals 6 times 8.4, which is 50.4, which is the answer. You could also set up a unit conversion, like doing 6 gallons 1 minute in your parenthesis. Great, let's keep going. You could also put a fraction answer. It's terminating decimal, so I don't care. It's fine. Okay, drill 3. Based on the graph, how many students did not respond May? Okay, so this is 8, 5, 11, and 13. And we want to know how many did not respond May. So that's these ones. And so that's 5 plus 11 plus 13. And that gives us 29, which is correct. Great, let's keep going. Okay, 10 fish weighing less than 5 ounces are placed in tank A. Okay, I'm just going to make a frequency table to make this information easier to understand. So we'll do value, so we'll do the weight first. Then we can do the frequency. So less than 5 ounces. Okay, so that's 0 less than or equal to W is less than 5. And then weighing at least 5 ounces, so 5 less than or equal to W less than 13. And then might be easier just make a histogram, kind of like that one we did before. And weighing more than 13 ounces. Okay, so W but no more than, I guess that includes this one. It doesn't matter anyway. Okay, so 10 fish, so that's a frequency of 10, 11, and then 12. Which of the following could be the median of the weights of these 33 fish? Okay, so we're going to do the position of the median is n plus 1 divided by 2. So that's 33 plus 1 divided by 2. I don't know what that is. 17. So we need to find the 17th data value. So we're going to cumulatively add the frequencies until we hit 17. So 10, didn't hit it. 10 plus 11, 21. Okay, so it seems like the median is in this row. And it has to be between 5 and 13. So too big, too small. Only one it can be is B. Yeah, so you see how helpful that formula can be. You got to really make sure you know this, guys. Position equals n plus 1 divided by 2. Okay, drill 4. Answer choice B. Good. Let's keep going. Has a mean of 33 and a median of 33. A new data set is created by adding 7 to each number in the original data set that is greater than the median and subtracting 7 from each number in the original data set that is less than the median. Which of the following measures does not have the same value in both the original and the new data sets? Okay, so the mean and median are measures of center. So the mean and the median are still that whatever that number is in the middle, which didn't get changed. And notice how the mean and median are the same. So that number in the middle didn't get changed, but everything else did. It just got moved farther away. It's just become more spread out. So instead of looking like this or something, right? It now looks like this. We added 7 to the ones bigger, so they got farther away from each other. So my point is the mean and median are left unchanged. Because if you add 7 to all those numbers, right, and then subtract 7, they're going to like kind of cancel each other out when you're calculating the mean. And then the median literally did not change. It's still in the same spot. So, so it's definitely not going to be these guys. The sum of the numbers, we were just kind of talking about this. The sum of the numbers depends on the mean, or the sum of the numbers determines the mean, right? So if you add 7 to all those numbers and then subtract 7 to all those other numbers and then add them up, all those 7s will cancel out. So the sum of the numbers is going to be the same. The only thing that's not going to change is the standard deviation. So you see the standard deviation, this one is more spread out. This new data set is more spread out, so it's going to have a higher standard deviation. So the answer is D. If you're having trouble seeing this, I highly encourage you to come up with some data set with a mean and median of 33, and then come up with a new data set where you add 7 to all the numbers bigger and less than that, and see what happens. Okay, drill 6. Which of the following could be the equation for a line of best fit? Okay, so first thing I'm going to do, you guys can't do this on the digital test, but I'm going to draw the line of best fit. So something like that. And I see that the y-intercept is going to be positive. It seems out of the two y-intercepts that 0.8 is more reasonable. So I'm going to cross off the ones with the 3 as a y-intercept. And now I'm going to just look at the slope. It's going up, so the slope must be positive. So the one with the slope of -3, that can get crossed out. So I think the answer is A. And let's see, that is right. Great, so if you want to, you can go and plug in a bunch of numbers and see if you get, like plug in 4 and see if you get about 13 or something. But I think reasoning it through like that, like check the y-intercept, cross out, check the slope, cross out, hopefully you get the answer. Great. Okay, a sample of 40 fourth grade students was selected at random from a certain school. Okay, so this is really important. A sample of 40 fourth grade students from a certain school. That is our population. So, as long as it was selected at random, which it is, we can generalize the results of this study to all of that part I underlined in yellow. So, all the fourth grade students from the certain school, which is answer choice B. Great. If they weren't selected at random, I suppose A would be right. It's just those 40 students. You see all students at the school. We didn't ask any fifth graders or third graders or anything, right? And then all fourth grade students in the county, we didn't ask students from the other schools. We only asked it from that certain school. So great. So yeah, really just underlining. That's what this question was about. Checking to make sure it's random and then underlining the population. That's it. Okay, drill 8. Non-linear. Okay, so if we're doing this by hand, you see how they all go 1, 2, 3, 4? So the y values should go up by the same amount. By a constant amount, constant rate of change. So this is plus 3, this is plus 3, and this is plus 3. So that one's linear, so it's not that one. This one's plus 4, plus 4, plus 4. That one's going up by a constant amount, so it's not that one. Plus 5, plus 5, plus 5. Okay, it's not that one. Let's look at this one. This is plus 6. This is plus 12. And this is plus 24. Okay, so that does not have a constant rate of change. So this is non-linear. And that's what the question wants. So the answer is D. I think in particular this is a exponential function, but they didn't ask us for that, so let's not worry about it. All right, so we have another, seems like confidence interval question, but this time we got a sample proportion. So we're going to do the sample proportion plus or minus the margin of error. So 15% plus or minus the margin of error of 2%. So 15 minus 2, that's 13% to 17%. If we change those to decimals, that's 0.13 to 0.17. And now it says there's 10,000 beads. So I had ones like this in my Ottocento video. What you do is you just multiply that percent by the population size. So 0.13 times 10,000 is 1,300. And then 0.17 times 10,000 is 1,700. So remember, guys, the sample proportion plus or minus the margin of error. That's what you had to know for this question. Okay, so 1,300 to 1,700. That is answer choice B. And that is correct. Great. So yeah, if you haven't watched my Ottocento video on confidence interval, go check that out. Okay, it says, what is the probability given that the person is at least 18 years old? Okay, so that's a target group. So at least 18 years old. That is just these bottom 3 rows. And we want to know greater than 65. So that's here. So we're going to do the probability is 25 over the total in that red box that I just drew. So 22 plus 26 plus 25. Again, you can just kind of pretend there's like 100 people. That's kind of what I just did here. It doesn't matter. Even if you change them all to decimals, you'll still get the same thing. And I'm getting 25 over 73 doesn't simplify. That is enough characters. You can do 5 characters, not including a negative sign. So 1, 2, the division sign, and then so it's 3, and then 4, 5. 5 characters, so that's acceptable. You also could have put the decimal, just put in as many decimals as you can. I would just use the fraction because it says you can use a fraction, so why not? You can mess up typing in a decimal. You're probably not going to mess up typing in a fraction because Desmos can just do it for you. So, okay, great. Let's keep going. Almost done. Okay, which estimates the amount by which the line underestimates the value of y when x equals 50. Okay, so let's look at 50. Okay, so the predicted y value is on the line, and the actual y value is the dot. So the actual y value is 65, and the predicted y value is, I don't know, what is that, 45, 46, 47. Yeah, let's go with 47. Okay, and to find the estimate, we just, the underestimate or overestimate, it just wants to know this distance here. We just subtract them. So 65 minus 47 is equal to 18, which is the correct answer. So there's a word for this in statistics. I mean, if you want to look it up, it's just they don't expect you to know this. It's called the residual. So the residual is the vertical distance of the actual y value from the line of best fit. To find it, you just subtract them. Again, they ask this in a roundabout way because they don't expect you to know residual. Great. Okay, I go over this in my Ottocento video as well. This is great. Okay, so the concept that they are testing us on here is that, I go over this in the Ottocento video, margin of error and sample size are inversely proportional. So if I go to do sample size, inversely proportional, the one with the bigger margin of error has the smaller sample size, and the one with the smaller margin of error, the opposite, inversely related, has the bigger sample size. I go over that in my Ottocento video. Think about it. If you ask more people, your survey becomes more accurate, and as a result, you have less error. So if you ask more people, you get less error. That's the idea. Okay, so, I mean, A and B have, sample A has the smaller sample size, so that is answer choice D, and that is correct. C is just wrong, right? It's just the opposite. And A and B are just off topic. The only other thing margin of error tells you about is standard deviation, which this question does not mention. So go watch my video if you want to learn more about that. Sample A had a smaller number of votes that could not be recorded. We don't know anything about that. I don't even know where they're getting that from. Sample A had a higher percent of favorable responses. That is true, but that has nothing to do with the margin of error. So those are both just off topic and wrong. The only two things they're going to ask you about this are sample size and standard deviation. most of the time, sample size. Okay, great. Okay, this is exactly what I was talking about, I think. Okay, very first thing, I'm going to underline these percent increase decrease, and we're going to calculate those multipliers. So let's do that. So 30% less, 1 minus 30 divided by 100. That's 0.7. And 1 plus, because it's an increase greater, 85 divided by 100. That's a percent multiplier of 1.85. So before we do anything, let's just get those jotted down so that we don't have to worry about it, you know? Okay, let's come back over here. Okay, so the number of crane flies. Okay, so why don't I use C for crane flies? And then I see this word, this magical word, is, which means equals 30% less than the number of ladybugs. Okay, so 0.7 times L for ladybugs. How about? And then it says the number of honeybees in the sanctuary. Okay, so when we use H, we see the magic word is, which means equals 85% greater. So 1.85 times the number of crane flies, C. Okay, now it wants to know honeybees and crane flies. No, honeybees and ladybugs. Okay, so you see how we have a common letter C. We want to get C by itself in both of them. So how about I actually move this over? And we can do, this one's already by itself, but this one we have to divide both sides by 1.85. So 1 divided by 1.85 gives me 20 over 37. So C is equal to 20 over 37 H. Again, I just did 1 divided by 1.85 on my calculator because I divided both sides by 1.85. Okay, so now I have these two equations, and they both have C by itself. So we can now set them equal. So 20 over 37H equals 0.7L. And we can now, we want to get H by itself because we want to know how many times greater is H, because it says that. See how it says the number of honeybees is. So that means H should be by itself. H is. H equals. So we're going to divide both sides by 20 over 37. 0.7 divided by 20 over 37 is giving me 1.295. So I believe that is actually the correct answer. So it's 1.295. Because it's 1.295 times the number of ladybugs. That is correct. Now, I'll do you one better. You could also go and quickly find the percent change, how much percent greater the number of honeybees is. And again, to do that, go over this in the percents video, you subtract 1 and then multiply by 100. So subtract 1, multiply by 100, we get 29.5. So the honeybees are 29.5% greater. They didn't ask you that in this question, but they totally will ask you that in another one. So make sure you understand that. So the honeybees are 29.5% greater than the number of ladybugs. Great. Okay, great. So notice how there's no increase or decreasing words, more, greater, fewer, less, nothing like that. This is percent of. So I'm just going to translate each of these to a sentence. So A is equals to 10% of B. So when you do a percent of, go over this in the percents video, you got to divide by 100, change the of to multiplication. So 210 divided by 100 is 2.1, and then times B. And if you want, we could just call that 2.1B. Now we're going to do the second one. So A is 30% of the number C. So we're going to write A equals 30 divided by 100 is 3, the number c. So 0.3 times c. Great. It wants us to relate c and b. So we are going to, oh, we got a by itself for both of them, so we can just set them equal. So let's do 0.3c equals 2.1b. And we want to get c by itself. So we're going to divide both sides by 0.3. 2.1 divided by 0.3 is 7. And c is p% of b. So 7 is the decimal. So to change it back to a percent of, all we do is multiply by 100. We don't need to subtract 1 or anything. So to change it back, we're just going to do 7 times 100, which is 700%. So you just put 700 as your answer. P equals 700. That is correct. Great. Okay, let's go back to the title slide. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. If you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math on all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.